right, this is Techmath1. We're looking at Chapter 2, Notes, out of the Blue Book. So let's get started. We've got we're looking at solving equations. So let's start with number 5 on page 56. So number 5 looks like this. We have negative 9 equals negative 3 plus t. So when we're solving equations, the name of the game is to get 1x equals. You want to get the variable all by itself. That's called isolating the variable. And then you want to make sure there's a 1 in front of it. So in this case, this is just a one-step equation because you got t plus negative 3 is equal to negative 9. And so I don't want that. I just want t equals. So it becomes a game of opposites. I have a negative 3 here. If I add 3 to this side of the equation, I add 3 to this side of the equation. And then I end up with the answer, negative 6 is equal to t. Now, if it gives you a rash to have it written backwards like that, you could rewrite it. It's an equal sign, so it really doesn't matter if this is first and this is second, or if this is first and this is second, and then solve it. But I have had students that they like the variable left justified. You'd still get the same answer. It would still be the same problem. It's just you'd have t is equal to negative 6. Either way is fine. All right, let's look at number 6. What do we got here? It looks like a little quick lightning round on number 6. We've got 12 plus x equals 4. We've got 20 equals p plus 30. We've got v minus 4 equals negative 5. And we've got 2 equals negative 9 plus y. It says, what number would we add to both sides to solve each one of these equations? So they don't want us to actually solve it. And in this case, so we would add negative 12. Or you could think of it as subtracting 12 from both sides. This one, we would add a negative 30 to both sides. This one, we would add 4 to both sides. And this one, we would add 9 to both sides. And so they just wanted us to actually solve that, or not solve it, just tell us how to solve it. So that was just the how-to. If we really wanted to, here, these are quick problems. Let's do them. Negative 12, that would be x equals negative 8. Negative 30, that would be negative 10 equals p. Plus 4, that would be v equals negative 1. And plus 9, that would be y equals 11. So there we go. Let's take a look at number 12. Oh, the F word, fractions. Got y minus 1 is equal to 7/8. So we would have to add 1 to both sides. And now this particular case, you could find 8/8 and write it as 15/8. Is that what they did? That is what they did. In this particular case, when it's a fraction and you're adding a whole number, you could write it as a mixed number. So if you just wrote y is equal to 1 and 7/8, that would be fine. That's not what they did. They did it like this. They said 7/8 plus 1 over 1, y equals 7/8 plus 8/8 for the common denominator, multiply by 8, top and bottom there, to get an 8 on the bottom, and then y is equal to 15/8. That's what they did. You could do it either way. All right. Okay, let's look at 2.2. I'd like to jump to number 17. So we're looking at 4 is equal to 4x. We're looking at negative 30 is equal to 3t. We're looking at negative 48 is equal to negative 6m. And then I also want to look at 18, that is negative 4t equals 0. That is 0 is equal to 7d, and that is negative 8 is equal to 8r. All right, so it's isolated. The variable's already by itself. So this time we want to, but we still need one x equals. So the coefficient, the number in front of the variable, has to be a 1, not a 4 or a 3 or a negative 6. So in this case, we divide both sides by 4, and that's 1 equals x. This case, we divide both sides by 3. That's negative 10 equals t. In this case, we divide both sides by negative 6. And what is that? 8. Positive 8, right? So, voila, we've got the answers. Now, the question comes up, well, wait. Why didn't I divide by negative 30? You always divide by the number that's in front of the variable. So the variable is always kind of driving our decisions when we're doing problem solving, all right? So this one, we divide both sides by negative 4. 0 divided by negative 4 is okay. That's 0. This, we divide both sides by 7. D equals 0 again. And this, we divide both sides by 8. And that's not going to be 0. Negative 8 divided by positive 8 is negative 1. All right. Then let's jump to number 23 on page 61. Same deal. We're just going to be working with decimals. So negative 1.5y is equal to 7.5, and 0.06 is equal to 0.3d. And so when we solve this, we divide both sides by negative 1.5 divided by negative 1.5. I think that one goes evenly. Let's see, y is equal to, this would be where you would bust out your calculator and do 7.5 divided by negative 1.5. That is negative 5. And this one, we divide both sides by 0.3, and that would be 0.2. I think, is that right? Yep, 0.2. All right. Excellent. Let's do 27 and 28 on 2.2. All right, so when we have a fraction in front, remember the name of the game is to get 1x equals. So there's two different ways to attack the problem. The easiest way, or the most efficient way, is to think about, all right, I want 1y here, so to get 1y when there's a fraction, I multiply by the reciprocal. And then what happens? Well, top times top, bottom times bottom. When you're multiplying fractions, numerator times numerator, denominator times denominator, and then reduce. So look, this becomes 2 over 2, which is just 1. So that's 1y, which is what we wanted. And that is 2 over 1 times 1 over 1, which is just 2. All right, let's do this one. Normally I divide by 2, but there's a fraction, and let's divide by 2 both sides. Now look, we have x is equal to 8/9 divided by 2. Well, remember how that works. We never divide fractions. If it's a division problem and there's fractions, we multiply by the reciprocal. So this gets flipped. We get 8/9 times 1/2. That divide turns into a times. Multiply by the reciprocal. 2 over 1 becomes 1 over 2. And then top times top, bottom times bottom. So that's 8/18. And then reduce. And now some of you may have canceled. That's fine. 4/9. At this point, some of you might have said, no, I canceled the 2 into the 8 and made it a 4, and then just did 4 times 1 and 9 times 1 and got 4/9 that way. That's fine. You could do it that way. That's canceling. Don't call that cross multiplying. That's not cross multiplying. Cross multiplying is what you do with proportions when you're working them out. We didn't cross multiply here. We could have if we wanted to. So there is another way to attack that problem. You can look at it like a proportion and use cross multiply. That means you put that over 1, and then you do 2x times 9 equals 1 times 8. That's cross multiply and solve. So you get 18x equals 8, and then you divide by 18, and then x is equal to the same thing, 4/9. There's a third way to do it, where you skip that, you skip this, and it's more like this. It's a very efficient way to do it, where you say, okay, normally I just divide by 2 like that, but because there's a fraction on this side, I'm going to multiply by the reciprocal. I'm going to think of that as a fraction, 2 over 1. I'm going to multiply by 1/2, multiply by 1/2, and there we are again. We get 1x is equal to 8/18, and then x is equal to 4/9. So this way is probably the least amount of work, the least amount of steps. But you've got to be aware that you're working with fractions. So that's how we'll do this one. Let's multiply by 4/5. Multiply by 4/5. Here I get 1/2. Here I get 0. So that was the easiest way to do that. Okay.